Okay, so here's some more examples using this mole ratio and the new and improved master plan. So here I've got a double replacement reaction between aluminum chloride and silver nitrate. And it says, suppose 36.9 grams of aluminum chloride react with excess silver nitrate. That just means more than enough, plenty. How many grams of silver chloride will be formed? So very first thing that we need to do is balance this puppy. So when I'm looking at this, I have 3 chlorines over here, which means I need 3 over here. And when I do that, I need 3 over here. And I have 3 silvers and 3 NO3s. Over on this side, I have 3 silvers and 3 NO3s. So I've got a 1 to 3 to 3 to 1 ratio. It says 36.9 grams of AlCl3. So here is my known. I'm reacting with excess silver nitrate, so that really doesn't come into the picture. I need to know how many grams of silver chloride will be formed. So I'm going from grams of my known to moles of my known, and then I'm going from moles of my known to moles of my unknown, and then from there I'm going to grams of my unknown. So my known, at first I'm going to be starting with AlCl3, and my unknown is going to be AgCl. Now, it says grams because this is a double replacement. These are both aqueous. They dissolve in water. AgCl is actually a precipitate, so we should be collecting a certain number of grams, like on a filter paper if we were to run it through a filter system, and the aluminum nitrate would be aqueous. So we're going to predict the number of grams of a precipitate we should form. So, that being said, let's start with our 36.9 grams of AlCl3. And remember, I'm going to label that so I know what the heck I'm dealing with. And then I need to know right here, to get from grams to moles of aluminum chloride, I'm going to need to know the molar mass of aluminum chloride. I'm getting 133.33 for that. And so next, if I look at my master plan, I just went from grams to moles. Now I'm going to go from moles of AlCl3 to AgCl. So I need to label this AlCl3, which means that needs to go on the bottom. So for every 1 mole of AlCl3, I'm going to make 3 moles of AgCl. And then to continue on, now I'm going to go from moles of AgCl to grams of AgCl, so I would need to say in every 1 mole of AgCl, how many grams would you have? So now I need the molar mass of silver chloride. So that's, I got 143.32 grams of AgCl, Cl, excuse me, not 3. So that means grams of AlCl3 cancel, moles of AlCl3 cancel, moles of AgCl cancel, and I'm left with grams of AgCl. And when I take 36.9, divide by 133.33, multiply by 3, and multiply by 143.32, I get something like 118.99 grams of AgCl. Okay, here's one last example. I have zinc reacting with hydrochloric acid to make zinc chloride and hydrogen. This is the reaction from the inside of your penny that you did when you reacted the inside of the penny, but the outside did not. It says, suppose 100 milliliters of 6 molar HCl are allowed to react with excess zinc. Remember, that just means more than enough, more than what's required. What volume of hydrogen gas will be produced? So first thing, as always, I'm going to balance this sucker. So I'm going to have a 2 here, and that should do it, because then that gives me 2 H's and 2 Cl's on the right. So this one is giving me the molarity of HCl as my given, and it's asking about hydrogen for my unknown. So if I'm looking up at the top, I'm going from big M down to moles, and then my mole ratio, and then I'm going to liters. And so my known is HCl, my unknown is hydrogen. So I'm going to start this time with my 6 molar HCl, and I'm just going to rewrite that instead of big M. Remember, we can substitute the units moles per liter. And then I know that I have 100 milliliters, which would be 0.1 liters. And so that right there is going to give me moles of HCl. Okay, so then I'm going to do my mole ratio. So I just went from here to here. Now I'm going to do my mole ratio. So for every 2 moles of HCl, right here, I have 1 mole of hydrogen gas released. And now I'm going to go from moles of H2 to liters of O2, and I'm actually going to use green instead. It's a little easier to see. For every 1 mole of H2, this is asking for volume, so I would release 22.4 liters per mole. So moles of HCl cancel, moles of H2 cancel, and I'm left with liters of H2. So if I multiply 6 times 0.1, that'd be 0.6. 0.6 divided by 2 would be 0.3, and 0.3 times 22.4 is going to give me my answer. And that's 6.72 liters of hydrogen. So that's the basics. Remember, this would be called, different stoichiometry problems depending on what you're trying to find, but using that mole ratio is really huge, and thank you for taking on this challenge. See ya!